This is example 3.3.4. It says determine the velocity relative to the shore if a current is 8 meters per second and the swimmer moves directly across at 6 meters per second. So basically what we have here is we have a current that is flowing this way. We want to swim directly across the river. And so we know that eventually we're going to be pushed on this path right here, because as we go this way at 6 meters per second across the river, the current is going to push us further down the river. So what we want to do is we want to figure out what this value is right here. When you look at it this way, it makes it a whole lot easier because you have 6 and 8, they're in different directions, so we can't just add or subtract them. They're not in the same x dimension or y dimension. So what you have to do is you have to go ahead and decide what you're going to do here. Since one is in x and one is in y, x and y, you can go ahead and say, okay, I got to combine these using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Or, in our particular case, it's going to be 8 squared plus 6 squared equals c. We're going to take the square root of that. 8 squared is 64, 6 squared is 36. So you have 64 plus 36, which is 100, which then we have to take the square root of. So our answer here ends up being 10 meters per second. Now the second part of this is you actually have to determine the direction too, because remember, velocity includes not only magnitude, but it also includes direction. So you need to figure out this angle right here. Now, you have all the sides of the triangle, so you can actually use any trigonometric function you want, but really what we have originally is given is the opposite side of this angle, and we have the adjacent side of this angle. The trigonometric function that we would use would be tangent of the angle equals the opposite over the adjacent. Or in our case, tangent of the angle equals 8 divided by 6. Now, in order to get rid of a tangent function, you have to do something called the inverse tangent. The inverse tangent is tan to the minus 1. What that does is it gets rid of the tangent on the one side. But remember, what you do to one side, you have to do to the other. So what we have really is theta is equal to the inverse tangent of 8 divided by 6. So we go, okay, make sure our calculator is in degree mode first of all. Put it in degree mode. We say the inverse tangent, which is just second in tangent, you see this tan and the minus 1, of 8 divided by 6, close the parentheses, you get theta is equal to 53.1 degrees.